There's a difference between a panel that works and a panel that looks professional. That difference is how the wiring is organized. I've seen panels where wires go in every direction, a tangled mess that works fine until something breaks and nobody can figure out where anything goes. And I've seen panels where every wire is routed cleanly through wire duct, labeled clearly, and terminated perfectly. Both panels might do the same job, but only one of them is built the right way. In this video, I'm going to show you exactly how professional panel builders route and organize wiring inside a control panel. This is the stuff they don't teach in school, but every professional panel builder knows it. Welcome back to Panel Design Pro. Before we talk about routing, you need to understand that inside every control panel, there are two completely separate worlds of wiring. The first is power wiring. This carries high voltage and high current, 480 volts, 240 volts, or 120 volts AC. Think of the wiring going from your main disconnect to your motor contactor and from your contactor to the motor terminals. Power wiring uses larger wire, typically 10 AWG, 12 AWG, or larger depending on the current load. The second is control wiring. This carries low voltage signals, typically 24 volts DC. Think of the wiring going between your PLC, your push buttons, your relays, your pilot lights, and your terminal blocks. Control wiring uses smaller wire, typically 16 AWG or 18 AWG. These two worlds must be kept physically separated inside the panel. Power wiring and control wiring should never run together in the same wire duct if possible. Why? Because high voltage power wiring creates electrical noise called electromagnetic interference. If control wiring runs right next to power wiring, it can pick up that noise and cause false signals in your PLC inputs, erratic relay behavior, and hard to diagnose faults. Keep them separated, and you avoid a whole category of problems before they start. The backbone of organized panel wiring is wire duct, also called cable duct, wire trough, or wire raceway. Wire duct is a plastic channel with slots or holes in the sides that wires run through. It mounts directly to the back panel and creates organized pathways for wires to travel between components. There are two orientations of wire duct in a typical panel. Vertical wire duct runs up and down the sides of the back panel, creating the main highways for wiring. Horizontal wire duct runs left and right between the DIN rails, creating the cross streets that connect components on each row. Together, the vertical and horizontal wire ducts create a grid, like a road system inside the panel. Every wire has a clear path to follow. Nothing crosses open air unnecessarily, and when you need to troubleshoot or modify the panel later, every wire is easy to find and trace. Standard wire duct sizes are typically 40 by 40 millimeters for control wiring and 60 by 60 millimeters or larger for power wiring. Always size your wire duct so it's no more than 60% full. Leave room for future wiring additions. Now let's talk about the rules professional panel builders follow when routing wires. Rule 1. Wires always travel through wire duct. Never run a wire diagonally across open air from one component to another. Every wire enters the nearest wire duct, travels through the duct to the right location, and exits to terminate on its component. No exceptions. Rule 2. Leave a service loop. When a wire exits the wire duct and travels to its termination point, leave a small loop of extra wire, about 2 to 3 inches. This gives you slack to re-terminate the wire if the connection ever needs to be redone. Cutting a wire too short and not being able to reach the terminal is one of the most frustrating mistakes in panel building. Rule 3. Never exceed 60% fill in wire duct. Overfilled wire duct makes it impossible to add wires later and creates heat buildup. If your duct is getting full, add another duct. Rule 4. Bundle and dress wires neatly. Wires going to the same destination should be bundled together with cable ties or Velcro straps. Keep the bundle tight and parallel. Wires that branch off should do so cleanly at right angles, not at random angles. Rule 5. Power and control wiring cross at 90 degrees only. If power and control wiring absolutely must cross them at a 90-degree angle. This minimizes the electromagnetic interference between them. Never run them parallel for any significant distance. A professionally wired panel doesn't just look organized, every wire is identified. Wire identification means every wire has a label at each end that matches the wire number on the schematic. If wire number 103 connects terminal block TB3 to PLC input card terminal 7, both ends of that wire have a label that says 103. Wire labels can be applied several ways. Printed heat shrink labels slide over the wire before termination and shrink tight. Printed sleeve labels clip onto the wire, or a simple marker on a piece of label tape wrapped around the wire works fine for smaller panels. Wire color coding is another critical identification tool. The most common color standard in North American industrial panels is black for AC line voltage, white for AC neutral, red for AC secondary or switched power, blue for 24-volt DC positive, white with blue stripe for 24-volt DC negative or common, green or green with yellow stripe exclusively for equipment ground, and yellow for interlock wiring from external sources. Always follow the color standards specified in your customer's spec. If no standard is specified, use NFPA 79 as your default. It's the most widely recognized standard for industrial machinery wiring in North America. The last stop for every wire is its termination point, the place where it connects to a component or terminal block. Professional panel builders almost always use wire ferrules on stranded wire before terminating into screw terminals. A ferrule is a small metal sleeve that crimp onto the stripped end of a stranded wire. It holds all the wire strands together and prevents them from spreading out and possibly touching adjacent terminals, which could cause a short circuit. Ferrules come in color-coded sizes that correspond to wire gauge. 18 AWG uses a blue ferrule. 16 AWG uses a gray ferrule. 14 AWG uses a red ferrule. Learn the colors, and you can identify wire gauge at a glance anywhere in the panel. When terminating a wire, always strip to the correct length. Too much bare wire exposed can cause short circuits. Too little, and the connection won't be secure. The general rule is strip length equals the depth of the terminal screw clamp, typically 8 to 10 millimeters for most terminal blocks. Torque your terminal screws to the manufacturer's specification. Under-torqued connections work loose over time and cause intermittent faults. Over-torqued connections damage the wire and the terminal. A torque screwdriver set to the correct specification is one of the most professional tools in a panel builder's kit. Let's recap what you learned today. Control panels have two separate wiring worlds, power wiring and control wiring, and they must be kept physically separated. Wire duct creates organized pathways. Vertical ducts are the highways, horizontal ducts are the cross streets. Wires always travel through wire duct, never across open air. Leave a service loop, never exceed 60% fill. Bundle wires neatly, and cross power and control wiring at 90 degrees only. Every wire is identified with a label at each end matching the schematic wire number. Wire color coding follows NFPA 79 or the customer's specified standard, and always use ferrules on stranded wire and torque terminals to specification. A professionally wired panel is something to be proud of. It reflects the quality of the designer and the builder, and now you know exactly what that looks like. In the next video, we're moving into PLC territory, PLC basics for beginners, what a PLC really is, how it's programmed, and why it's the most important skill in modern industrial automation. Hit subscribe so you don't miss it, and drop a comment below. I'd love to know what your biggest wiring challenge has been. I'll see you in the next one.